How's it going, everybody? I'm sorry I'm a little late with this video here, but I just want to quickly run through 1-3. Now again, 1-1, 1-2, and 1-3 should all be very much review for each and every one of you, but these are important foundational concepts in order for us to be able to move forward with this calculus class. So as we discuss, as we continue our discussion on functions, we're talking about obviously new and old functions, but those specific functions, how they transform and move on an XY coordinate plane based off of different factors. So, transformations, first and foremost, we can say that a translation is probably the first category of a transformation. And we notice that our graph moves either left or right, up or down, based off of what happens to a specific function. Now, anytime a function itself, the entire function, we are adding a value or subtracting a value from that, as we can see down here with y equals f of x plus c. When we're adding c to the entire function, that's going to result in a shift up or down, okay? When we are, in fact, affecting the function just with respect to the x variable, we actually shift it in the opposite direction because we see this x minus c, and it would go either left or right. So if we end up subtracting a value, we're really going to the right, and if we end up adding a value to x, then we're just shifting it to the left. And we can see, how that works here. Notice plus c shifting to the left, minus c shifting to the right, plus c to the entire function, shifting it up, minus c to the entire function, shifting it down. Okay. And then we just have a key concept here. This just kind of puts it all and sums it all up for us. One thing that I would recommend that you do is if you take screenshots of these important concepts and you create a page, whether it be a Word doc, a Google doc, whatever you want to call it, and you're just copy and pasting these key concepts in there, that's a great way to prepare for the final exam, because then you can just flip back very quickly and easily. And then you'll notice here what also happens is we have a transformation where we're stretching or reflecting our function as well. So when we're stretching or reflecting our function, you'll see that if you make x negative, then you would flip it over the y-axis. If c being your constant in front, okay, is greater than 1, then we're going to stretch it. If it's less than 1, we are compressing it. All right, other way around, I'm sorry. We're stretching it if it's less than 1 here and compressing it, moving it in. Okay, and then we notice that if we are taking the opposite of the entire function, we're actually flipping it over the x-axis. So I'll flip over the y-axis, we're negating x. I'll flip over the x-axis, we're negating the entire function. And then we're stretching or compressing based off of what the coefficient in front of the function actually is. Okay, and there you go. There's your key concept again that I recommend that you copy and paste. Other functions that we talked about were, in the past we've dealt with trigonometric functions, the cosine, the sine, and the same thing really happens there. You'll notice we're talking about a stretch and compress right now. Okay, notice the coefficient in front of the function here too. The function is stretching, right? And then we have a compression of that function because it is less than 1. Okay. Now, one thing that I strongly recommend that you do as well, and notice if it's happening to the x value, how it affects it as well, entire function or the x value. Okay, now one thing I recommend that you do is become very familiar with using a graphing calculator. I know that in this particular class, and to be honest with you, I'm kind of surprised by this, but the teacher who taught this class before only required you to have a scientific calculator. In many ways, a graphing calculator is really the only way to go here. However, I will allow you to complete this class without a graphing calculator by modifying things. But if you have one, very beneficial for you to mess with, work with, use, graphing these functions, using the trace function to see how your value of x changes as y changes. That's going to help you to really wrap your mind around the graphical aspect of calculus. Okay. We talked about the transformations here. Here we go. You can hear my kids yelling in the background. Okay. Same type of thing though, but here we're just looking at the square root function, but notice the function behaves in the same way. We shift it up or down, right, based off of what happens to x, and then it would be left or right based on what happens to the entire function here, right? And then we also have a stretch or a compress, and then we also are flipping this function, okay? So notice how this is negative, so it reflects over the x-axis, all right? The x is negative, it reflects over the y-axis, right? Now we have, combinations of functions. So I like to call it the composition of functions, but, we're adding a function f and a function g. F plus g of x is the same as f of x plus g of x. F minus g of x is the same as f of x minus g of x. The way that we say this, and I'll repeat it again, this is read as f plus g of x. It's not multiplication here. We can't divide both sides by x. This is the function, but it's the function of f of x plus g of x. And this is the function of f of x minus g of x. Okay? We call this an intersection. This is something that you'll see in discrete math if you've ever taken discrete math. But this would be called the intersection of a and b, or f plus g here. Okay, and then we also notice our domain here, our domain for this function right here, because we know that we cannot have a negative value under the square root. If we do, then that would result in an imaginary number. And so because of that, we have a restriction on what our values of x can be. Therefore, we know that x cannot be a number greater than 2, can it? Because if it was greater than 2, then we would have 3 here. 2 minus 3 would be a negative 1, which would result in a negative value under the square root. And that's why our domain is we can have any value that is equal to 2 or less than 2 going off to negative infinity, because any of those values would not produce a negative value under the root. Okay? And notice how we use, the parentheses here and the brackets here. The parentheses mean that it goes off and off forever and ever and ever, and it's not ever equal to anything, right? But here, it's our domain includes 2, and that's why we have the bracket here. Notice this domain between 0 and 2, the reason for that is because we can't have a value less than 0 here, because if we did, that would be a negative number. All right, this domain has to account for all parts of the function, and that's why our domain is restricted to only values between 0, so equal to 0, and 2, okay, equal to 2. So equal to 0 and 2, and anything in between there. Okay. This is just other, functions, combinations of functions. We have f times g of x. We have f divided by g of x. And these domains change. Notice g of x can't be 0 here in this function, because if it was 0, then we would be undefined. We can't have that. F of x equals x squared, and g of x equals x minus 1. If we were to do this here, notice that x minus 1 would be in the denominator, which means that x cannot equal 1, because if it was 1, then the denominator would equal 0. And then we can use our interval notation to denote what the range is in this case. Okay, this U symbol, all right, just like this was intersection, this would be union. Okay, so notice these two functions, they don't intersect at all, right? Or these two ranges don't intersect. Between negative infinity and 1 is completely different from 1 and infinity, but we can say that, yes, one or the other. This represents your and, this represents your or. When we just continue to move through these, the biggest one, I would say the most difficult one, is computing the composition of functions. So we say f of g of x here. The procedure is called the composition of functions. This helps us to understand too if two functions are in fact inverses of one another, because if when you compute the composition of functions, so if you were to compute f of g of x and then also g at f of x, and they both equal the same thing or both equal to x, then we could then say that those two functions are inverses of one another. Okay, and they're gonna, talk about that now, but this is another way of writing it: f of g of x, f of g of x. Okay, that's the composition of functions. Okay, let me see if they have an example here. So yeah, here's a good example right now. So if we have the function f of x and the function g of x, and we want to compute the composition, that would mean we're computing both f of g of x and g at f of x. F of g of x, okay, you take the function f and you put within it the function g. Here's the function the function f of x, and if I put within it the function g, I'm going to take x minus 3 and I'm going to put it inside of. I'm going to replace x with x minus 3, and that's why we put x minus 3 in parentheses here and square the whole thing. Now, a different composition of this function would be calculating g at f of x. That means we're going to take the function g and we're going to plug in the function f for x here. That's why instead of that we have x squared minus 3. Now if we were to go ahead and expand this, we'll notice that these two things are different from one another. Therefore, these two functions are not inverses. If this equaled this, essentially if f at g of x equaled g at f of x, then we could say that these two functions are inverses. Okay, here we go. And that's basically 1.3. So the next time you see me, I'm going to be introducing chapter 2. We know that there's a number more sections in chapter 2. Again, I'm just going to reiterate, and it's important for you to be pausing this video as I go through it, taking notes, trying examples. If you have a hard copy of the book like I have right here, you should maybe have that book open too while you're going through this presentation, because there's more contained within the book that's going to provide more opportunities for example problems for you to move through it. So hopefully you're having a nice weekend. Look forward to checking in with you guys all on Tuesday. Remember, we are meeting at 9 o'clock at night now. Okay, so we are not meeting at 6 anymore. That's to help our friends in Hong Kong so they don't have to get up at 5:30 in the morning to be ready for our 6 o'clock class. So, hope all is well. We'll talk to you later.